Ever pondered why in a right-angled triangle, the square of the hypotenuse equals the sum of the squares of the other two sides? This is the crux of the Pythagorean theorem, a cornerstone of geometry. It's an ancient mathematical principle credited to the Greek mathematician Pythagoras, but evidence suggests it was known to the Babylonians and Egyptians long before his time. Now, imagine a right-angled triangle. Label the hypotenuse C and the other two sides A and B. According to the Pythagorean theorem, the square of C is equal to the square of A plus the square of B. Simple, isn't it? But how can we prove this? For this, we turn to Euclid, another Greek mathematician. His proof of the Pythagorean theorem involves constructing geometric figures and drawing comparisons based on their properties. First, consider a right triangle. Construct a square on one side and another square on the other side. Now, draw a perpendicular line from the hypotenuse to the adjacent side of the triangle. This creates two new triangles within the squares. These triangles are similar to the original right triangle. Next, compare the ratios of corresponding side lengths in these triangles. The ratios are equal, confirming the similarity of the triangles. Now, consider the squares on the two sides of the triangle. Their areas are proportional to the squares of the corresponding side lengths of the triangle. By equating these areas, we find that the square of the hypotenuse is equal to the sum of the squares of the other two sides. This completes the proof of the Pythagorean theorem. It's a fascinating demonstration of how simple geometric constructions can reveal profound mathematical truths. In summary, we've explored the Pythagorean theorem, a key principle in geometry. We've seen how it relates the squares of the sides of a right triangle and delved into Euclid's elegant proof of this theorem. This journey underscores the beauty and power of geometry, a field that continues to shape our understanding of the world.